Hey folks, this is going to be the first video of section 7.3. I'm going to break this section up into several videos because this section is slightly lengthy. The other thing is that I'm going to be working through this section slightly out of order, so just pay attention as you go along so that you can follow along in the notes. We'll start out at the beginning though. Notice that we've got this potential question here. We don't really know whether or not cosine of a minus b, does that really equal cosine of a minus cosine of b? And when you think about it at a moment, yeah, it seems as though we should be able to do something like distribution, and that should work. But what we find if we use some examples. So for instance, let's use for angle A, let's use a pi over 2. And for angle B, let's use 0 radians. And so in this particular case, if this were to be true, let's look at the two sides. Cosine of angle A minus angle B would equal cosine of pi over 2 minus 0. And then, of course, pi over 2 minus 0, if we're working in the group first, that's equal to cosine of pi over 2. You take out your unit circle, and the cosine of pi over 2 is equal to 0. All right, so now let's look at the other side and use those exact same values for angles A and B, and let's find out if it's equal to 0. So what we find first off is that this is going to be the cosine of pi over 2 minus the cosine of 0. We already know that the cosine of pi over 2 is 0. And take a look at your unit circle. What is the cosine at 0 radians? Well, at 0, the cosine is 1. So 0 minus 1 is negative 1. And we can see here that, no, these two are not equal to each other. So it takes one simple example to show that, yeah, this here distribution does not work. I cannot jump from something like this into something like this right here. All right, so if I can't do that, there has to be some way of figuring out the cosine of two angles that are being subtracted. And so we have identities for that. And what you see here is that the identity for cosine of angle A minus angle B, which is the one we were just looking at, is going to be cosine of angle A times the cosine of angle B plus, you'll notice these two signs here do not match up, plus the sine of angle A times the sine of angle B. And if we are adding our angles together, this is going to be cosine A times cosine B minus, once again, these two signs don't match up, minus the sine of angle A times the sine of angle B. Now, normally, I don't write this in two separate lines. When I give you a formula sheet for this, I only write the single line view here. And so let me point that out. You've got cosine of either angle A plus or minus angle B. This is going to be cosine A cosine B minus or plus. So you'll notice here the signs are opposite each other. So whenever it's a plus, we use a minus in here. Whenever it's a minus over here, we use a plus here. So minus or plus sine A sine B. You will hear me use a shortcut for this. And so normally I will say something like cos cos minus plus sine sine. And so you'll know what I'm talking about as far as that's concerned. Now, I'm going to skip down in the notes, and I'm just simply going to give you, so if you'll go all the way down to page 7-3, where it talks about, it gives more identities, the sum and difference identities for sine, and the sum and difference identities for tangent. So let's go ahead and give you these identities. That'll be the end of the first video, and then we will move on. All right, so for sum and difference identities for sine, again, notice that we've got sine of either an angle plus an angle or an angle minus an angle. And you'll again notice that the first term is the same, sine A cosine B plus or minus sine B cosine A. And one thing that I want to point out here is that these two pluses and minuses, they match these two pluses and minuses. So what I like to say on this is that the signs, S-I-G-N, on sine, S-I-N-E, match. The signs on sine match. So it's a play on words there. And so once again, this is going to be the single liner that you'll see on your formula sheet for this. Now, I do want to point out that Lyle in the textbook, he does use, it looks a little bit different, but I want to show you that it is still the same thing. He says sine of angle A times the cosine of angle B plus or minus the cosine of angle A times the sine of angle B. So he simply takes these two in this term and he uses a commutative property to trade the order of those. So that's what you'll see in Lyle or in my lab. All right, now let's take a look here at the sum and difference identities for tangent. This is for tangent of angle A plus angle B and for tangent of angle A minus angle B. And so you'll notice these are actually big fractions. So we have tangent A plus tangent B all over one big fraction, 1 minus tangent A times tangent B. The minus version is very similar to that. Let me just point your attention, though, to the one-liner, as I like to call it, that's on your formula sheet. So we have tangent of angle A plus or minus B is going to be tangent of angle A plus or minus the tangent of angle B all over 1 minus or plus the tangent of angle A times the tangent of angle B. Once again, you do have these on your formula sheet, so you will be able to view them. And again, the ones on your formula sheet are only these one-liners. I do not give the separated versions, so just be sure that you're comfortable with those. All right, I'm going to end this particular video and come back in the next video and start doing some examples.